Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is the Mechanics for May-June 2023, and the code is 9709/42. Okay, so let's move on to question number 1. For question number 1, a particle of mass 1.6 kg is dropped from a height of 9 meters above horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done against air resistance. Okay, so let's say, for example, this is the diagram. This is a mass, 1.6 g is the weight, right? And then from here, initially, because it's drop, so it means that the initial u is 0, right? The initial velocity. Then from here, this is the ground, and the height here is 9 meters. Okay, just before hitting the ground, the v is going to be 12. All right, so from here, we need to get the work done. So basically, there are two methods to solve this question. I'm going to show you both. The first one is using work energy principle. So for work energy principle, then you can get the work done directly. Okay, so now this means increase in KE. KE is the kinetic energy, plus increase in PE, gravitational potential energy, equals to total work done. Okay, just for your information, the left hand side here, these two terms plus together is basically the increase in mechanical energy. Okay, all right. So now the initial KE, the increase in KE. Increase in KE is basically the final KE, final kinetic energy, minus initial kinetic energy. Okay, plus the increase in PE is final PE minus initial KE, initial PE. Okay, equals to total work done is basically the work done to speed up the body minus the work done to slow down the body. Okay, which means now we don't have the work done to speed up the mass, the particle. All right, therefore I will just write minus work done, that is 0, minus work done to slow down the particle is actually the work done against the air resistance. Alright, so now final KE. So when you look at the diagram here, the formula for kinetic energy, okay, the KE is basically half mv squared or half mu squared, right? So from here, I know that it's going to be half. My m is 1.6. Then the v is given 12, so which is 12 squared, minus the initial KE means that it is in the beginning, right? So which means 1.6, but then the u is 0. So here is 0 squared plus, now the PE, potential energy, the formula is mgh. Okay, so the m is 1.6, then the g is 10, the gravitational acceleration, then the h is 9. This is our h. That is a final PE because it has been traveled for 9 meters, alright, from u equals to 0 until the ground. Then the initial PE. Okay, wait. This is the initial PE because one final PE means that it's already reaching or hitting the ground. So the height will be 0. So then it will be 1.6 mgh is 0 minus 1.6. The initial PE means that in the beginning it is 9 meters from the ground. So it will be mgh, h is 9. Okay, then equals to minus work done against air resistance. Alright. So then from here, I will get the first term is going to be 115, right? So here I'll get 115.2. Then the second term is 0. Because of the 0 here, this is 0. The third term is 0. The fourth term, when you calculate, you will get negative 144. Alright, so now we need to get the work done. So which means we need to get this work done. But there's a negative there. So I will move the negative to the left hand side. Okay, that means it's basically negative of the subtraction equals to work done against air resistance. Therefore, the work done okay, so therefore the work done against air resistance will be negative, or when you calculate this, it will be positive. Alright, so it will be 28.8 joule. That is the work done. Alright, this is the first method. Now the second method is using the V squared minus V squared equals to U squared plus 2AS. Alright, we don't use the energy. So then together with the Newton's second law, this is a second method. Now from here, since you are given the V, U, the S, then we can find the A first. Alright, so I will say that it is 12 square equals to 0 square plus 2A. The S is going to be 9. Then from here, I will get 144 equals to 18A. Therefore, my A is going to be 144 divided by 18. Then you will get 8 meter per second squared. Alright, so then I will use the after the Newton's second law. So then my F equals to MA. Okay, so when you refer to Newton's second law, now look at this diagram. We have the weight 1.6 G, then there will be the R. Okay, so this R is going to be the force, resistance, the force by the air resistance. Alright, so by looking at this, so I know that the particle is moving down with the A, then it will be 1.6 G minus R equals to MA, according to the Newton's second law. So I will get 1.6 G minus R equals to, the M is 1.6, the A already found. Okay, so from here, I can just move the negative R to the right side and move the 1.6 times 8 to the other side. So I'll get R equals to 1.6. Now the G will be replaced by 10. Then minus 1.6 times 8. Then you will be getting 3.2. This is your R. Now after this, right? Now remember, we need to get the work done. So I will say work done against the A energy, or I would say, yeah, against the A energy, sorry, against the air resistance, it will be R times D, because your work done formula is actually F times D. So now our F is the R. Okay, so here equals to the R already found just now, 3.2. And the particle has traveled for 9 meters. Therefore, the D is 9. Then at last, I will be getting 28.8 joule. So therefore, we have two methods to solve this question. Alright. Now, for question number 2. Two particles A and B of masses 3.2 kg and 2.4 kg respectively lie on a smooth horizontal table. A moves towards B with speed v meter per second and collides with B, which is moving towards A with the speed of 6 meter per second. In the collision, the two particles come to rest. Find the value of A. Okay, so let's say this is the particle A. It is moving towards the B. Then this is the particle B moving towards the A. Okay, so for the A, the MA is 3.2 kg. Then the MB is 2.4 kilograms. Now, the speed of the A is V. So I will treat, right, the velocity towards the right side as positive. Okay, then for the B, it will be 6 meter per second. So here I will write UB equals to minus 6, right, because I treat the motion to the right side as positive. Right, but then when I draw my label here, I shouldn't label minus 6 because the arrow already shown. So I will write 6 here. Then after the collision, both stops, right, not moving anymore. So VA equals to VB equals to 0. This is the A and here is the B. Alright, so based on this, if you need to get the V, means that we need to refer to the conservation of linear momentum. Okay, so conservation of linear momentum says that the momentum before the collision is same as the momentum after the collision, which means the formula is MAUA, that is the momentum for the A, plus MBUB equals to MAVA plus MBVB. Alright, so from here, M is 3.2, the UA is V, plus MB is 2.4, the UB, look at the arrow, is opposite, alright, opposite direction as the A. That means I have to write minus 6. So when you label the diagram, it should be positive. But then after the collision, both comes to rest. That means here will be 0. Alright, so from here, when you simplify, you will get 3.2V minus 14.4 equals to 0. Therefore, you can get the V now. So 3.2V is 14.4. Then the V will be 14.4 divided by 3.2, which is 4.5 meter per second. So that is the solution for the V. Okay, now B, find the loss of kinetic energy of the system due to the collision. Okay, so now we need to refer to the conservation of mechanical energy. Alright, so initial kinetic energy, because it does not involve the PE here. So initial kinetic energy will be same as the final kinetic energy. Okay, so from here, when you look at the diagram, alright, so we know that the kinetic energy formula is half mv squared or half mu squared. So from here, I will write initial kinetic energy is basically half ma ua squared from the particle A and half mb ub squared. Okay, so here will be half. The ma is 3.2, the ua is 4.5, then you square it. Okay, it's given here. Alright, you have found the v is 4.5, the v is the ua. Alright, then now plus half mb, the mb is 2.4, then the ub is minus 6, then you square it. Now the first one, it will be 32.4 and the second value will be 43.2. So at last I will be getting 75.6 joule. Okay, now we know that initial kinetic energy will be same as final kinetic energy, but when you refer back to the question, both come to rest. Okay, come to rest means that the kinetic energy is lost. Alright, therefore our final kinetic energy is basically the loss of kinetic energy. Which is same as the initial kinetic energy. Okay, so that's the solution of part B. Now, question 3. Coplanar forces of magnitudes 30 newtons, 15, 33, and p newtons at a point. This is a point. In the directions shown in the diagram. Tangent alpha is 4/3. Okay, no. The system is in equilibrium. Now, A, show this equation. So, since the system is in equilibrium, now we need to resolve the forces vertically and horizontally. Okay, so now when you look at this the 15 newtons and 30 newtons, I need to resolve both vertically up, right? And then for the P and 30 newtons, I need to resolve them down. So when you resolve, let's say the 30 newtons and 15 newtons, so when you resolve them up, alright, we actually use this angle, but then this angle is not given, then I'm going to use the alternate angle. So when you use alternate angle, that is sine. Okay, remember that. So same for the PN. So I should use this red angle, but then the red angle is not given. I'm going to use the alternate angle, which is the theta, then I'm going to use sine. So it means that when I resolve all these four forces, it will be sine of the given angle, the alternate angle. Okay, so now I will resolve vertically. Right, and I assume vertically is positive, right? Which means now when I resolve 15 newtons vertically up, I will get 15 sine alpha, and then together with the 30 newtons I resolve, it will be 30 sine theta. Okay, so I have these two vectors where I resolve upwards, then it will be same as the downwards forces because they are in equilibrium. Okay, the system is in equilibrium. So when I resolve the Pn downwards, it will be P sine theta because I'm using this angle. So P sine theta plus then the 30 newtons, I resolve it vertically by using the alpha. So it will be sine alpha. Alright, so now you are given sine theta and sine alpha both sides. Therefore, I will group it first. Alright, I will move the P sine theta to the left hand side and then this 15 sine alpha to the right hand side. So at the same time, I will get 30 sine theta minus P sine theta equals to 33 sine alpha minus 15 sine alpha. So then from here, I notice that the sine theta is in common on the left hand side. So I can take out the sine theta and then bracket 30 minus P. Right, now right hand side, I have 33 sine alpha minus 15 sine alpha. Then you will get 18 sine alpha. And now you are given tangent alpha is 4/3. So to get sine alpha, I have to draw a right angle triangle. Let's say this is alpha. So the tangent is basically opposite over adjacent sides. So opposite, you see, tangent alpha is 4/3. That means this is the opposite side and this is the adjacent side. So our opposite side is 4. This is the 4 and this is the adjacent side. Now, this longest side is the hypotenuse. So based on Pythagoras theorem, it should be square root of 3 squared plus 4 squared. That means you are getting square root of 25, which is 5. Okay, so from here, I will get 18 sine alpha is going to be 3/5. Then when you calculate this value, it's going to be 14.4. So when you look at the part A here, the answer is already given because you want to show this, right? Obviously, we need the 14.4 over 30 minus p. So I have the 14.4 here. I just need to move this 30 minus p down. Okay, so it means I get the sine theta as the subject. So I let this be the first equation. Now, next is to resolve the forces horizontally. Okay, so when I resolve the forces horizontally, I will get this. This one move down, here move down. Okay, then this one move up, this is move up. So it means that if horizontally, I will have two directions. Okay, one pointing right, another one pointing left. So these two will be grouped together, and the 30 and also the PN will be grouped together. So remember, see, when I resolve my 5n down, which is a yellow, let's say I change this to green arrow, then this will be the red arrow. Okay, so I'm using the given angle alpha, both also alpha, means that now when you resolve, it will involve cos. Okay, so then I will be getting 15 and cos alpha plus 33 and cos alpha. That will be the total force towards the right hand side. So now my working will be 15 cos alpha plus 33 cos alpha, then equals to the red arrow. So it will be 30 cos theta plus p cos theta. Okay, so for the left hand side, 15 plus 33, it will be 48. Then cos alpha equals to, now the cos theta is in common, that means I will factorize the cos theta, then I will get 30 plus p. Okay, again, the cos theta, you have to get it from this triangle. So the cos is basically adjacent over hypotenuse. Right? So I will get 3 over 5. Okay, I did a mistake in the previous step. The sine alpha. Sine alpha is opposite over hypotenuse. This is 4 over 5. Okay, small mistake here. Then for the cos alpha, I will get 3 over 5. That is 48 times 3 over 5 equals to cos theta bracket 30 plus p. Then again, now you simplify 40 times 3 over 8. Yeah, 3 over 5. 48 times 3 over 5, sorry. It will be 28.8 equals to this expression. Now, look at the given form, 28.8 over p plus 30. Okay, so it means that I need to get the cos theta as a subject. So this is my second equation. So from here, right, to get the square of first term plus square of second term equals to 1, I have the sine theta and cos theta. So it means that now we need to refer to identity. Cos squared theta plus sine squared theta is 1. Then now just substitute first and second into this identity. Then I will get the answer. So you will get 14.4 over 30 minus p squared. That is my sine theta. Then my cos theta will be 28.8 divided by 30 plus p. Then you square it equals to 1. So with this, we have shown the identity or shown the equation. Okay, now question B. Verify that p equals to 6 satisfies this equation and find the value of theta. So we have to solve two parts. So when you verify means that you show that p equals to 6 by substituting the value into the previous working. Okay, so from here I will just rewrite 14 from A, 14.4 over 30 minus p squared plus 28.8 over p plus 30. Okay, or p plus 30. Okay, so here I should write p plus 30 then. Okay, then here squared equals to 1. So to verify, I need to prove left and right side. So I will start with the left hand side. It will be 14.4 over 30 minus p squared plus 28.8 over p plus 30 squared. So when p equals to 6, my left hand side will be 14.4 over 30 minus 6 squared plus 28.8 over 6 plus 30 then squared. Okay, so from here the first term is 0.6 squared, then plus the second term it will be 0.8 squared. So when you calculate this, it will be 0.36 plus 0.64. That means you are getting 1. So the 1 is same as the right hand side. Therefore, p equals to 6 satisfies the equation. Okay, so this is how we verify it. Alright, so now the next one is to find the data. Okay, so to find the data, we refer back to our previous working. We know that sine data, you can use the sine data or you use the cos data, it's up to you. So I'm going to use the sine data. Sine data is 14.4 over 30 minus p. And we know that the p is 6 now. So from A, equation 1, sine data equals to 14.4 divided by 30 minus p. Okay, and now your p is 6. So sine theta is 14.4 over 30 minus 6. That means this is 0.6. So when sine theta equals to 0.6, then your theta is going to be 36.9. So this is the angle in the first quadrant. So when you use a calculator, inverse sine theta, it will be 36.9. Let's say I show you step by step. Okay, inverse sine 0.6, it will be 36.9. Alright, so that's the solution of this question. So here we only choose one value because based on the diagram. Alright, obviously your theta is acute angle. Okay. Now, next question, number 4. An athlete of mass 84 kilograms is running along a straight line. A, initially the route is horizontal and he runs at constant speed of 3 meters per second. The athlete produces a constant power of 60 watts. Find the resistance force which acts on the athlete. So we know that power is F times V. Okay, so now power is given 60. The F is the resistance force here because we don't have driving force. Alright, so here the F is going to be resistance force and then the V is the speed 3. Therefore, your F is 60 over 3, which is 20 newtons. Now B, the athlete then runs up a 150 meters section of the route which is inclined at 0.8 degrees to the horizontal. Okay, let's say this is the diagram. Here is 0.8 degrees. So this is the athlete, let's say, right? Runs up 150 meters. That means here is 150 meters. Now the speed of the athlete at the start of the section is 3. So U equals to 3 meters per second. And he now produces a driving force, constant driving force, 24 newtons. So D equals to 24 newtons. The total resistive force which acts on the athlete along this section of route has constant magnitude 13 newtons. So this is the resistance force, which is 13 newtons. Use an energy method to find the speed of the athlete at the end of 150 meter section of route. What is this V? Okay, so just now we know that the mass of the athlete is 84 kilograms. So I will write here M equals to 84 kilograms. So now to use the energy method, okay, so I will say work done. Let me check the space. Okay, total work done. This is a work energy principle. Total work done is basically now total work done is increase in mechanical energy. Okay, so now it is same as increase in KE. KE is a kinetic energy plus increase in PE, the potential energy, right? So the gravitational potential energy. So now from here, the total work done is basically the D. Okay, D is a driving force. So I will continue over here. So 24 minus, okay, the work done is basically FD. All right. So you can write FD times I mean the 24 is a driving force times 150. Okay, I better write it here because I need more space. 24 times 150, that is the work done to speed up. It is the work done by the driving force, then minus the resistance force. Work done by the resistance force means that it is 13 times 150. That is the total work done. Okay, so that equals to increase in PE means that, increase in KE. This is same as final, right? I don't want to write so much. So final KE minus initial KE. I've shown you just now. Then the increase in PE is basically final PE. This is final PE minus initial PE. Okay, so from here, the final KE means when the athlete reaches the top. Alright, so here it will be half. The M is 84. The formula is half mv squared. So V is not given. Then minus half initial KE. The initial velocity is 3. So the 84 times 3 squared, that is the increase in KE plus increase in PE. So final PE, the athletes will be here. Okay, let's say I draw it here. This is the V, how much? Alright, so when it reaches here, remember, we need to find the MGH. The PE formula is MGH. So this is MGH. Alright, I need to know what is my H. H is the vertical height. So then I need to resolve my weight. So this mass is 84 kg. Okay, so that means this is 84 g. So now my formula MGH, M is 84, the G is going to be 10, the H, the final PE means that it already reaches here. Now remember, this is 150. Okay, so I have to resolve this 150 down. Alright, so when I resolve it here, that means I supposed to use this angle, but then this angle is not available. I'm going to use this. So if I use the alternate angle, which means that is sine, so it will be sine 0.8 degrees. Okay, minus 84G. The H is going to be 0 because this is the initial PE. So at first it is at the bottom, alright, that means it is 0. Okay, so then now I just need to simplify all this and I will be getting the answer. Alright, so basically I don't need this 84. Okay, sorry. For the left hand side, when you calculate this, you will get 1650. Then the first one, half times 84v squared, it will be 42v squared. And then the second term here, when you calculate, it will be minus 378. I get it for the increase in PE, plus, right, I remain the rest. So 80, okay, I miss out one term here. This is not just sine 0.8. I have to resolve this distance. Okay, I resolve this down. That means it's 150 sine. I miss out the 150. Sorry. So here should be 150 sine 0.8 degrees. Alright, so now this 150, this 84 times 10, it will be 840. So I will just write in this form first, then sine 0.8 degrees. So now I need to get the V, okay? What is the V here? That means I will keep this term on one side. The rest of the terms will be moved to the other side. Means that these two terms will be moved, okay? And then I will write this as 42v squared equals to 1650 plus 378 minus 840 times 150 sine 0.8 degrees. Now, I will calculate all these values one shot. Now, here is going to be 268.7653. I give more decimal places. Then the V square is to divide the value by 42. And you will get 6.3992. So at last your V is going to be square root of this value, and you will get 2.53 meter per second, which is correct to 3 significant figures. Okay, now question number 5. A particle of mass 0.6 kilogram is placed on a rough plane. So all these are rough plane, which is inclined at an angle of 35 degrees to the horizontal. The particle is kept in equilibrium by a horizontal force of magnitude P Newton. This is a P Newton acting in the vertical plane containing a line of greater slope. The coefficient of friction between the particle and the plane is 0.4. Find the least possible value of P. So now, from here, I know that since the mass of the particle is 0.6 kilogram, then the weight is going to be 0.6 g. Okay, so now, because you need to find the least P, so when it is least P means that we will expect, or the particle is about to slide down, okay, because of the least P. So when the particle is about to slide down, which means, okay, your frictional force will be moving up. Okay, so this is my FR. Sorry. So this is a FR, frictional force. And then now, for the PN, I can just extend it to the right side. Okay, so from here, I will resolve the forces. And one more thing is, since it is rough, I will have another force, which is the R. Sorry, the normal reaction, which is the R. Okay, then here I have to consider this angle, this direction. So I have to resolve now the forces which are along the plane and also perpendicular to the plane. So if let's say I start with perpendicular to the plane, means that is in this direction. Okay, so I will get R because I show pointing up as positive. So I will get R equals to, now when you resolve like this, I have to resolve my weight. Okay, and this is my Pn. This is my Pn. Then I also have to resolve my Pn because all of this will be perpendicular to the plane. Now, look at the diagram here. Since here is 35 degrees, that means this is alternate angle. And I know that total of these two angles is 90 degrees because this is a triangle. Which means now you see these two angles plus together is 90 degrees. On other words, this here, okay, here is going to be 35 degrees. Okay, so that total of these two angles will be 90 degrees. Alright, and then for the Pn, this is going to be the alternate angle. That means here is going to be 35 degrees. Alright, so now by looking at this, then I can say R is same as 0.6 because this is 0.6 G. Then I resolve using 35 degrees. That means that is cos 35 degrees plus when I resolve the P, I'm not using the 35 degrees here, but sorry, I'm not using its own angle, I'm using 35 degrees. That means it's going to be sine. So I'll get P sine 35 degrees. Okay, so now from here, I get my R. Okay, don't forget, you have the frictional force. So the frictional force here is mu R. Okay, the mu is given 0.4. So I will get 0.4 times this whole formula. So it will be 0.6 G sine 35 degrees plus P sine 35 degrees. And let this be the first equation. I don't want to solve first. Now, next is I resolve the forces along the plane. So when I resolve the forces along the plane, now I will have this moving up together with the Fr, okay, equals to this moving up. Alright, so now I will get P cos 35 because I resolve the P and along the plane using 35 degrees. Once it reaches here, I have another Fr. So I just add up both of them. So it means that now I will write P cos 35 degrees plus Fr equals to, now the other force will be this. Okay, I resolve it, it will be here. So then now when I resolve, I'm using the 35 degrees, which is the alternate angle, which means I'm going to use sine. Okay, so it will be 0.6 G sine 35 degrees. Alright, so I let this be the second equation. Now since I have the Fr in the second equation, so I will substitute first into second because my first equation is the Fr. So I will get P cos 35 degrees plus, okay, so here you can just do expansion, right, but I will not times in, I will not simplify it, I will just rewrite first 0.4, then 0.6, and the G I change to 10 sine 35 degrees, then plus 0.4 times P. So it will be 0.4 P sine 35 degrees. All these are my Fr. That equals to 0.6, the G I replace by 10. After that, sine 35 degrees. Okay, so I need to get the P. that means I have to group the terms with the p. At the same time, I factorize the p as well. Okay, so here I will get p cos 35 degrees plus 0.4 sine 35 degrees equals to, now this term will be moved to the right side. Okay, and I will simplify. 0.6 times 10, it will be 6 sine 35. Then the red color here, the second term, which is this, right? I will move to right side and try to simplify all these simple numbers. So then I will get minus. So 0.4 times 0.6, then times another 10 is like 0.4 times 6, which is 2.4. Okay, then I will get sine. Wait, let me check. Is sine or cos? Okay, wait. I did a mistake here. I write wrongly. You see here, this is sine, this is cos. But when I copy, I wrote sine, which means now I have to change all this to cos. Okay, so this is cos, then this is going to be cos. Alright, it should be cos 35 degrees. Then here I'm getting cos 35 degrees. Right? So then my P is going to be the division. So I will get 6 sine 35 minus 2.4 cos 35 degrees divided by cos 35 degrees plus 0.4 sine 35 degrees. So then you will get 1.41. That is the P, the least P. Okay, so the least value of P is 1.41. Alright, so now, next question, number 6. A particle P starts from rest, means that U equals to 0, and moves in a straight line, so U equals to 0, T equals to 0, and move in a straight line from the point O. At time t seconds after leaving O, the velocity of P is v meter per second and is given by this expression, where B and C are constants. P has velocity 8 meter per second when t equals to 4, alright, and 13.5 meter per second when t equals to 9. Show that B equals to 3 and C equals to negative 0.5. Okay, so now just rewrite. Your V is BT plus CT to the power of 3 over 2. So I will use the values 8 when t equals to 4. So when t equals to 4, V is 8. Alright, I'm not going to use this initial because initial means that everything is 0. So now I will get 8 equals to B times T. So means that it will be B times 4 plus C times 4 to the power of 3 over 2. So from here I will get 8 equals to 4B plus 8C. Therefore, my B, okay, I divide the whole equation by 4. Then 2 equals to B plus 2C. Therefore, my B is going to be 2 minus 2C. That is the first equation. Then now the next one is when t equals to 9, the V is 13.5. Which means, alright, 13.5 equals to 9t, okay, I direct replace now, plus 9 to the power of 3 over 2c, not 9t, 9b, because your t is 9. So from here I will get 13.5 equals to 9b plus 27c. So then I will substitute the b into this. Alright, let's say this is second. So first substitute into second will be 13.5 equals to 9 times 2 minus 2c plus 27c. Then you will get 13.5 equals to 18 minus 18c plus 27c, which means you will get negative 4.5 is 9c. So our c is negative 0.5. Okay, and then to get the c, just substitute into the first equation. So from first, the b is 2 minus 2 of negative 0.5. Then it will be 3. Okay, so this is how we show the the b and c values. Now part b, find the acceleration of p when t equals to 1. So we know that acceleration is dv over dt. So before we get the differentiation, now better to write down what is the v first. So the v replace the b and c, so it will be bt, means that it is 3t, then minus 0.5 t to the power of 3 over 2. So now I just need to differentiate. So the a is dv over dt. So differentiate 3t to get 3, then remain the 0.5. To differentiate the t to the power of 3 over 2, you can just differentiate x power n. Use this formula, it will be nx power n minus 1. So now, when I bring down the power 3 over 2, then I remain the t. Now the power of 3 over 2 must minus 1. Okay, because of n minus 1. So 3 over 2 minus 1 is half. Then from here, when I simplify, I will get 3 minus 3 over 4 t to the power of half. Okay, that is my a. Then now, to find the acceleration at t equals to 1. So when t equals to 1, the a is going to be 3 minus 3 over 4 to the power of, times 1 to the power of half. That means it's same as 3 minus 3 over 4. Then you will be getting 2.25 meter per second squared. So that is our acceleration. Now see, find the positive value of t when p is at instantaneous rest. It means that the v equals to 0. Okay, what is the t? And find the distance of p from O at this instance. This is a s distance. So now we need to find what is the t when v equals to 0. Okay, so I need to refer back to my v. v is 3t minus half, or 0.5 t to the power of 3 over 2. So now I will write v is 3t minus 0.5 t to the power of 3 over 2. So when v equals to 0, 0 is 3t minus 0.5 t to the power of 3 over 2. Then from here I can factorize the t. So I will get 3 minus 0.5. When you factorize the t from t to the power of 3 over 2 means that you still have power half. Okay, so from here when you multiply two of them equals to 0 means that either the first one equals to 0 or the second one equals to 0. So the t power half I can change to square root t. So t equals to 0 is the initial. That means we can just ignore this. Alright, then now 3 equals to half square root t. Then now square root t is going to be 6. Hence I will get the t. T is going to be 36. So that is my t value. And now find the distance. So the distance is the s. So s is integrate v dt. So now I'm going to do the integration. The v is 3t minus 0.5 t to the power of 3 over 2 dt. And now when you integrate, it's going to be 3t squared over 2 minus 0.5. When you integrate, okay, you must remember, integrate x power n. You are adding 1 degree. So it is x power n plus 1 over n plus 1 plus c. Therefore, this is going to be t to the power of 5 over 2 divided by 5 over 2, then plus c. So when I simplify, I will get 3 over 2 t squared. Now, this negative half times divide by 5 over 2, you will get negative 1 over 5. Then t to the power 5 over 2 plus c. This is your s, but then I need to find what is the c value. So we refer to the initial condition. Means that at first, when t equals to 0, the s is 0. That means now 0 equals to 0 plus c. Hence my c is 0. Okay, so the s is going to be 3 over 2 t squared minus 1 over 5 t to the power 5 over 2. But then you need to find the distance at this instance, means that at t equals to 36. So when t equals to 36, your s is 3 over 2 36 squared minus 1 over 5 times 36 to the power 5 over 2. That means you will be getting 388.8 meters. Okay, so if you want to round up, then it will be 389 meters, which is correct to 3 significant figures. Alright, now D, find the speed of P at the instant it returns to O. So when it returns to O means that the displacement S will be 0. Okay, so now our S already found just now. So S is this, right? 3 over 2 t squared minus 1 over 5 t to the power 5 over 2. So I will let the S be 0 first. Then 3 over 2 t squared minus 1 over 5 t to the power 5 over 2. And factorize the common term. Let's say I factorize the t to the power of 2. Okay, I factorize t power 2. You may factorize 1 over 10 because here you have over 2 over 5. So I will just factorize. Let's say I factorize 1 over 10 t squared. Then it will be easier. So when I factorize 1 over 10 from 3 over 2 means that it will be 15. Okay, then minus 1 over 5. From 1 over 5, you factorize 1 over 10 means that you have 2. So then it will be t to the power of half equals to 0. So it means that now 1 over 10 t squared equals to 0, or 15 minus 2 square root t equals to 0. So from here I will get 15 is 2 square root t. Therefore square root t is 15 over 2, which is 7.5. Then now my t is going to be square of 7.5. Then you will get 56.25 seconds. Alright, so then this is not the final answer because you need to get the speed. So now our speed formula, go back to the previous question. This is the velocity, and the scalar of velocity will be the speed. So I will just copy this, 3t minus 0.5 t to the power 3 over 2. So when t equals to 56.25, the v is going to be 3 bracket 56.25 minus 0.5 times 56.25 to the power of 3 over 2. Okay, then you will get minus 42.1875 meter per second. Remember, this v is the velocity. And now you need to find the speed. So the speed is going to be the magnitude of this, because the speed is the scalar and velocity is vector. So I will just ignore the negative sign and round up the answer to 3 significant figures. So that is the solution for part D. Okay, question number 7. Two particles P and Q of masses 2 kg and 0.25 kg respectively, so you are given here, are connected by a light inextensible string that passes over a fixed smooth pulley. The particle P is on an inclined plane at an angle of 30 degrees, which is here, to the horizontal. The Q is hanging below the pulley. 3 points A, B, C. Okay, so you are given the distances. Now P is released from rest at A, right, means that U equals to 0. Then with string taut and slides down the plane. So means that it's moving down. This is going to moving up. To move up, this is a tension. Here is a tension. Okay, this is the weight. Here is going to be the weight. Now, during the motion of P from A to C, okay, A to C, Q does not reach the pulley. The path of the plane A to B is rough. This is rough. With coefficient of friction is 0.3 between the plane and P. The path of the B and C is moved. A, first part, find the acceleration of P between A and B. Okay, so now I will not consider all, but I will just consider A and B. Just this part. Okay, so initially the U equals to 0. Alright, so now we expect the particle P moves down. That means the frictional force will be going up. This is our frictional force, Fr. Okay, and then now I need to get the R first, because I have a Fr here. My R is basically perpendicular to the plane. This is my R. So I need to resolve. Right? So for your information, this is 30 degrees. That means here is the alternate angle, which is 60 degrees. And then here is going to be 30 degrees. Okay, so from here, I will get my R first. What is my R? Because I need to get the Fr later on. So from the points P, okay, or particle P, the R is going to be a resolve. Okay, the R is going to be 0.2 G cos 30 degrees. Wait, let me check. It is not 0.2 G. Okay, this is 2 kg, right? So mistake. 2 kg means that it will be 2 G. Okay, so I will get 2 G. It will be 2 G cos 30 degrees. So the G replaced by 10. The cos 30 is basically square root 3 over 2. Then you will get 10 square root 3. Okay, so now the Fr, frictional force. The Fr is mu R, and then the mu is given 0.3. So I'll get 0.3 times this amount. It will be 10 square root 3. So 0.3 times 10 is basically 3. So I'll get 3 root 3. This is my frictional force. Okay, now to solve this question, acceleration, I'm going to use the Newton's second law, which is F equals to ma, and consider the particle P first. So the particle P is moving down. Alright, so when I'm moving down, I will have to resolve this 2G because it's moving down. It is the same direction as the A now. Okay, so I have to resolve this 2G along the plane. So when I resolve, I'm not using 30 degrees. I'm not using its own angle, but I'm using 30 degrees. Therefore, it is sine. Okay, so I will get 2G sine 30 degrees. It will be same as or minus this F and T. Okay, Fr and T, it will be ma. Right, because the particle is actually moving down. So now I will write 2G sine 30 degrees minus Fr plus the tension equals to 2a. Then now I will replace my Fr. So, and at the same time, the G will be replaced by 10. Sine 30 is half. Then minus Fr is 3 root 3. Then this minus you times in, it will be minus T equals to 2a. Okay, then from here, I will simplify. It will be 10 minus 3 root 3 minus T equals to 2a. This is my first equation. Now, my second equation comes from the particle Q. So the Q will move up. So when move up, just involve these two forces. Therefore, it is T minus 0.25 G is ma, 0.25 times A. So it will be T minus 0.25 G equals to 0.25 A. This is my second equation. And when you look at the question here, we need to get the acceleration, which is the A, which means we need to eliminate the T. So by looking at these two equations, the first one is minus T, the second one is positive T. Therefore, I will just add up these two equations. So first plus second, alright? The minus the T will be cancelled off, then I will get 10 minus 3 root 3, then minus 0.25 G. The G will be replaced by 10 equals to 2A plus 0.25A. It will be 2.25A. Alright, so now simplify. It will be 10 minus 3 root 3 minus 0.25 times 10. It will be 2.5. That equals to 2.25A. So at last your A is going to be, okay, all these values divided by 2.25, then you will get 1.024 meter per second squared, which is equals to 1.02 meter per second squared. That is our A, acceleration. Okay, so remember this acceleration is just from A to B, okay, because it is rough plane. So I would label here A to B. Okay, this is my A. Now done for this part. Part 2, hence find the speed of P at C. Okay, so now you need to find what is this speed. So from here, since I have found the A and I know the distance of the AB, then I can find what is the VB. Okay, I need to find what is my VC. The question is actually asked for VC, but then before VC, I get the VB first. So then I will consider from A to B. So from A to B, alright, V squared is U squared plus 2AS. So VB squared is U squared means initially it is 0. Okay, the A already found. So I will get 0 squared plus 2A. Okay, now since we need to get the A, use the A, I will use 1.024 for the calculation. So 1.024, the S is given, which is 0.8. Because the distance from A to B is 0.8. Then from here, I get 1.6384. Therefore, my VB is 1.28 meter per second. So once I found the VB, okay, so I found the VB 1.28. Now, to get the VC, so I cannot use back the A because this A for rough plane, remember? The BC now is a smooth plane, means that I need to resolve again. Okay, so the A has been changed. So then now, from B to C, okay, B to C, my P, I just use back the previous equation, these two, but then I ignore the FR. No FR now. Okay, means that I cancel this. Alright, so it will be 2G sine 30 minus T equals to 2A. Then, when I refer to the previous calculation, this 2G sine 30 is basically 10. Right? So I will just direct jump to this and then ignore the 3 root 3. So I will get 10 minus T is 2A. This is my third equation. And now same for the Q, particle Q. Alright, so basically particle Q has no change. Just copy back this. Okay, so then from here I can simplify. This is 0.25 times 10, which is 2.5. Because the G is 10, so I'll get 2.5 equals to 0.25A. So now I solve these two equations to get the A. So again, minus T and T, you plus these two equations. So 10 plus negative 2.5 is 7.5. The right hand side is 2.25a. Therefore, your a is 7.5 over 2.25, and you will get 10 over 3. I leave it in fraction. Now I know my a already, 10 over 3. Means that here is going to be a equals to 10 over 3. And now the S is given, A found, the VB already found. To get the VC, use back the same formula. V squared equals to U squared plus 2AC. So V squared equals to U squared plus 2AC. But then now your V is a C. Okay, the U here is actually the VB. Right? Or probably I can just write UB. Okay, so when you do labeling, here I write UB. Okay, so just replace all the values, then you will get the answer. Then I will get the UB squared. I will use back this 1.6384, 1.6384 plus 2, the A just found, 10 over 3. The S is given, which is 1.2. Okay, the distance B to C, 1.2. Then you will get 9.6384. Therefore, my VC is 3.10. Okay, that is my speed at C. Speed of P at C is going to be 3.10 meter per second. Right, so now B, find the time taken from P to travel from A to C. So from A to B, from A to C, we need to find the time, right? From A to B, then B to C. So I will use V equals also from A to B. I'm going to use, because we know all the UV already. So I will use VB is UA plus AT1. Okay, so VB already found, 1.28. The UA initially is 0. Remember, just now the A equals to 1.024. Okay, this is with the frictional force. So 1.024 T1. So now your T1 is 1.28 over 1.024. Then you will get 1.25 seconds. So from B to C, all right? So VC is UB plus AT2. So the VC already found just now, which is 3.10. Okay, so from here I will say I find the VC in correct to more decimal places first. Right, because I'm going to use this value for the next calculation. So I will get 3.1046 equals to UB. The UB is 1.6384. Oh, sorry, this is the squared. Okay, the UB is this 1.28. Then the A we just found, 10 over 3 T2. So from here, I will get 10 over 3 T2 is this, move to the other side, becomes minus. Then you get 1.8246. So your T2 is 1.8246 times 3 over 10, which is 0.54738 seconds. Alright, so then you can just leave in this form, or I will just say the time taken from A to C equals to T1 plus T2. So it will be 1.25, already 3 significant figures, then that means the T2 better just leave it correct to 3 significant figures. Then I will get 0.547, then I plus 0.547, it will be 1.80 seconds. Right, when you round up together, then it will be, okay, here I can just round up to be 2 decimal places, because 1.25 already 3 significant figures. So here I will just write 0.55. Okay, so that is the time taken from A to C. Alright, so we already solved the whole paper. Thanks for watching. Please subscribe to my channel if you enjoy watching my video. Thank you. Bye.